This course is a production of ITM Marketing. Visit us on the web at www.itmmarketing.net. Before you start your course, here are a few tips. Go at your own pace. You can pause the course at any time. And if you'd like to see any part of the course again, just rewind it and view it as many times as you need. Welcome to ITM's course on stencil printing for beginners. In this course, you'll learn the goals of stencil printing, the basic theory of printing, the printing parameters, the defects that can be caused in the printing process, and you'll also learn a little bit about printing equipment. The goal of stencil printing is to deposit a specific amount of solder paste onto specific areas of a substrate. These areas are typically surface mount pads. This needs to be done consistently in a mass production environment. The first step in the printing process is alignment. Automated stencil printers are equipped with automated vision systems. These vision systems use alignment marks called fiducials that exist on both the board and the stencil to align them to each other before printing. The board and stencil are then brought together by the printer. Step 2 is printing. The board is brought to the stencil, and then a squeegee is moved across the stencil, pushing paste through the apertures of the stencil and onto the surface mount pads. Step 3 is separation. The stencil and the board are separated very carefully. With fine pitch devices, this separation becomes very important. If the separation happens too quickly, some solder may remain in the stencil, causing defects. Finally, the results. A perfect print should be well aligned with all of the deposits being of the same height. Deposits should also have clearly defined shapes and complete volumes. No paste should be left between surface mount pads. As stencil printing becomes more complex, with pitches becoming finer and finer, the printing process becomes more difficult. The printing process can involve many different variables and parameters. Some of these parameters include print pressure, print speed, separation speed, and board support. Depending on the type of equipment you have, you may have more or less parameters. There are several different types of printing defects that can be caused by problems with the printing process. We'll cover just a few of the most typical ones here. Insufficient depositions can be caused by several factors. If you have a properly designed stencil and well-controlled input variables to the printing process, this problem is usually caused by poor paste rheology. This means that the solder paste is compromised in some way, and resulting in insufficient depositions. Bridging is another common defect. Bridges are typically caused by a buildup of solder paste on the underside of the stencil. The bottom of the stencil must be cleaned frequently to avoid bridges. This can be done manually or automatically on some stencil printers. Misalignment is another common problem with printing. Misalignments can be caused by problems with the vision alignment system or from boards that are not being held securely during the printing process. Eliminating the problems can be difficult depending on the process. Here are some tips. Eliminate paste buildup on the bottom of the stencil, either by hand or with an automatic wiper. Monitor your paste condition. Minimize the atmospheric effects on your paste with environmental control systems. And control your print parameters. Stencil printers can come in many shapes and sizes. Some are semi-automatic, some fully automatic, and some even manual. Here are pictured just a few types of stencil printers you might find in your production process. This course has been a production of ITM Marketing. Visit us on the web to find more courses and other valuable information for the electronics manufacturing industry. at www.itmmarketing.net.